All right, here we go. Day two, we are just going to build off of what we already know about polynomial functions. And specifically, we're going to talk about what happens inside of a polynomial function if our zeros, our real zeros, happen more than once inside of that polynomial function. Okay? And that happens to be multiplicity. So this word right here, multiplicity, means when real zero occurs more than once. Okay? All right. So the degree of a polynomial, leading coefficient of a polynomial will tell you what the function's end behavior looks like. Again, that's what we talked about yesterday. So this should go relatively quickly. If I have an even degree polynomial with a positive leading coefficient, remember we're relating that to a quadratic. So if it's positive and even, I know both ends are going up. Again, the reason why I'm dotting this is because the inside, remember, of a polynomial, depending on the degree, changes, right? But the ends of the graph are going to stay the same, right? Okay, so we're relating an even degree polynomial's end behavior, how it acts at the end, to a quadratic. Same thing that happens with a negative leading coefficient and it's even. Both ends, again, are going to go in the same direction, and they are going to go down. Again, the middle of the graph is what changes. Okay, odd degree positive leading coefficient, we're relating that to a positively sloped line, remember? Okay, so if a positively sloped line looks like this, and again, the ends are like that, but the middle of the graph is what changes. And then same thing with an odd negative degree leading coefficient. I'm going to have a negatively sloped line, but we know that if the degree is 3, 5, 7, 9, 11, and so forth, the middle of the graph changes, but the end behavior of the graph stays the same. Okay. Examples 1, 2, and 3. Identify and sketch the end behavior. I would strongly encourage you guys to pause this video, please, and do all three of these yourself, because after you unpause this, I am going to have all of them done for you. You can check it, and we can move on since this is something we did yesterday. All right, if we take a look at these three examples, they're very self-explanatory and things that we've done yesterday, so I'm not really going to spend a whole lot of time explaining them. Hopefully you did get them right, and you understand why you got them right. If you do have a question, I'll be more than happy to answer that question through email, or if you want to hop on the teacher support hour, if you happen to be in class while you're watching this video, you're more than welcome to ask me then. All right, so multiplicity is the new thing that we are going to talk about for the remainder of these notes. Multiplicity, again, here's the definition that we talked about at the beginning, how many times a particular number is a zero for a given polynomial. Okay, so just so we understand, okay, multiplicity is just how many times, like, is this zero happening multiple times? That's why it's a multiplicity. Okay, so do you guys agree in this particular example, I have x is equal to 0, I have x is equal to -3, and I have x is equal to 1 as far as zeros go, correct? Okay, if we look at the degree of each one of those, we can see that 0 is happening one time. So it has a multiplicity of 1. Okay, and again, this is all right here underneath. I'm seeing that -3 happens twice, right? That 0 happens twice, so it has a multiplicity of 2. And 1 happens 3 times, so it has a multiplicity of 3. If I can, right here, guys, if you noticed, I have x plus 3 squared, right? So the 0 is -3. What do you notice at -3 if I took a picture there? That's a quadratic, right? At 0, we know that the multiplicity here is 1. It's a linear 0, right? The degree is 1. Well, if I were to take a picture here at 0, what's there? It's just a line. Does that make sense? Okay? All right, we got one more to go. Back to our previous example here. At 1, we have a multiplicity of 3, which means if I were to take a snapshot or a picture of the graph at that 0, should I see a cubic graph? You are darn tootin' I should. And do I see one? You are darn tootin' I do. Okay? Make sense? All right, let's do this. Let's graph some stuff. All right, so let's talk about what's happening at that specific zero the higher my multiplicity gets, or if my multiplicity changes. So do you guys agree that number one, this polynomial is an odd function because it's a linear function, right? Do you guys also agree that this factor is really only happening one time? So it has a multiplicity of 1, right? Well, if we were to graph this thing, this is just a line. The y-intercept is -1, right? So -1. Okay, and then I'm going to go up 1 and over 1. So up 1, over 1. There's my other point, right? And then here's my line, right? Well, at this 0, guys, if I took like a snapshot, okay, I took a picture, not of the whole thing, but just at that 0, what do you notice? What's happening at that 0? It's literally a line, yes or no, right? And that should make sense because the degree of this particular factor is 1. The degree of that particular 0 is 1. Therefore, the picture, if you were to just take a picture of, just right at that 0, you would see that at that 0, there is a line. Does that make sense? Okay? All right. So graph across the 0, bam, there it is. All right. Now, what happens if the multiplicity is 2, right? So let's take a look at this. So if you notice here, I have a factor of x minus 1 again, but the multiplicity here is 2, right? That means that the 0 happens twice. Well, if we were just to take this in isolation and we knew nothing about multiplicity, you would say that this thing is in vertex form, right? Okay, so let's just graph this thing. What's happening? Well, if I were to graph this thing in vertex form, I know that I'm really just moving it right 1, and then I have the parent graph, correct? So if I move this thing right 1, I'm going to go up 1 and over 1. Up 1, over 1, over 1, up 1. So that's part of my parabola. And then if I go over 2, I'm going to go up 4. And then same thing on this side, okay? So I go up 4 here. I go up 4 there. All of this stuff we should know and is I think hopefully becoming easier and easier for you. So we've just graphed y equals x minus 1 squared because it's in vertex form, all right? Now, what I want you to do, just like we did with our first example when the multiplicity is 1, if we were to take a snapshot, okay, at that 0, what is happening at that 0? Well, there's a parabola literally at the 0 of 1. And hopefully it makes sense that there's a parabola there. Why? Because the multiplicity is 2, right? The degree is 2. And what do you know, what graph do you know is produced when I have a degree of 2? It's a parabola, right? Because it's quadratic. So if we were to just go back real quick, and hopefully we solidify this knowledge here, okay? So what happens if my multiplicity is 3? Well, again, if we were to take this in isolation and literally just graph y equals x minus 1 cubed, I hope everybody knows how to do that, because what we would do is just move the parent graph to the right 1 unit, yes? Okay, so there's my inflection point there. What happens if I were to cube 1? Well, I would go up 1, right? So there is my point there. What would happen if I were to cube -1? Well, then I would go down 1. Okay? All right? And I'm sorry that's not nearly as even as it should be. And then what would happen if I were to cube 2? Well, I would go up 8. Yes, that's 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay? So I go over 2 there. And up 8 there. So I would have my graph that looks something like this. And hopefully everybody knows that is the graph of a cubic. Now again, if I were to take a snapshot at this 0, so a picture, not the entire thing, but just a picture at that 0, what do you notice? Is there literally a cubic function at that 0? Yes. And it should make sense why that is the case, because the degree of that particular 0 is 3, which is really, really cool, I feel like. Okay? So again, if we were to go, let's move on down here to examples 4 and 5. Okay, so it says example 4, we have y equals x minus 2 and x plus 3. So we want to find the end behavior, zeros of the function, state the multiplicity, and graph it. Okay, well, first, let's do the end behavior, guys. End behavior. Well, if the degree of this is 1 and the degree of this factor is 1, then the degree of the entire thing, hopefully everybody can see pretty easily here, the degree of the entire thing would be 2, yes? Because I'm just adding my exponents. The degree here is 2, which means it's an even and it has a positive leading coefficient. Therefore, I know the ends are going to go up. So if I were to write the end behavior would be as x approaches infinity, y is approaching infinity. As x approaches negative infinity, my y is approaching infinity, right? Okay? Now, specifically, I know my zeros are at x equals 2 and x equals negative 3. So if I were to graph this thing, I need a point at negative 3. And I need a point at 2, yes? So my graph is going to look something like that. All right, it should make sense that it is actually a parabola because the degree here is 2. We know a degree 2 polynomial is quadratic and produces a parabola. Real quick, the multiplicity. So I know my 0 of 2 has a multiplicity of 1, right? Because that's how many times it happens. Again, if I were to take a snapshot at 2, right, a picture at that 0, is it just a line going through that 0? Yes. Yes, it is. Same thing with negative 3. So again, I would just write as, so x is equal to negative 3 has a multiplicity of 1 as well. Okay? All right. I would strongly encourage you to pause the video. I am going to graph this, write the end behavior, all of that stuff, while you guys are doing this on your own. All right, there it is. There's the example. Again, I know it has a degree of 2 because each multiplicity here is 1. So if I add those exponents together, remember, if I'm multiplying things, I add the exponents together. So the degree would be 2, so I know it's quadratic, I know it's even, therefore both ends are going down because of this negative leading coefficient, and then I answer the questions. All right, we're going to do example 6 together. I will pause it and let you guys do then example 7, okay? So we have 2 more where we're looking at the factors and we have to come up with the graph, okay? So first thing we do, we have to, if we're going to graph this thing, we have to find the degree of the actual polynomial, right? And we don't really want to spend time multiplying all of these factors out, right? So what we can do, like we said previously, is we can look at the degrees here, okay, or the multiplicities of each factor. Well, a 1 plus a 2 is 3, right? So if we were to multiply all this out, hopefully you guys can see this in your head. This guy would become x squared, right, if I were to multiply that out. This guy would just be x, so x squared times x, I add the exponents, would be x to the third. And an easy way to do that, again, is just to add the multiplicities or add the degrees of each factor. So the degree here of the whole polynomial, if I were to multiply it out, would be 3. So now I know the end behavior, don't I? Because if the degree is odd and I have a negative leading coefficient, I know the ends of my graph. And again, I'm relating that to a line, right? So I know a negatively sloped line looks something like that, right? But I also know that I'm not actually drawing a line or creating a line. I'm creating a polynomial with degree 3. So I have to get rid of everything in the middle, right? That's my job now that it's a polynomial. I am now going to come up with what it looks like in the middle, okay? But before we do that, let's answer some questions. So as far as end behavior goes, I know as x is approaching positive infinity, my y value is approaching negative infinity, right? And the other way, as x approaches negative infinity, my y value is approaching positive infinity, okay? The zeros of my function are x equals negative 2 and x equals 1. As for the multiplicities of each, I know that x equals negative 2 has a multiplicity of 2, and x equals 1 has a multiplicity of 1. Okay, now here's where the exciting, fun stuff comes in. So at negative 2, I have a 0, and at 1, I have a 0, okay? And I have to start up here in this corner, correct? Based on this guy right here. So I'm going to erase that and start a little bit more over this 0. So I know I have to start here. What do I know is happening at negative 2? Well, I have a degree of 1, don't I? Oh, I wrote these the wrong way. This should be a 1, okay? And this should be a 2, okay? So what do I know is happening at the degree, or sorry, at the 0 of negative 2? Well, it has a multiplicity of 1, and that's linear, right? We know that if it has a multiplicity of 1, that's a degree 1, that's a linear function. So I know that it has to go through negative 2 like a line, like I just did, okay? Next, the 0 of 1 has a quadratic, okay? Has a degree of 2 or a multiplicity of 2, which produces a quadratic. So at this particular 0, I need to have a parabola. Let me get rid of this n, okay? So let's take snapshots of each one. Again, at this 0, I should have a line because the multiplicity is 1, right? The degree is 1. That is the case. At this 0, if I took a snapshot, if I erased everything else and just looked at that 0, I should have a quadratic, and I do. So I know I did it right. All right, pause the video. Can you please do example 7 by yourself? All right, here we go. So in example 7, you see we have it's a degree 3 again, and the reason it's degree 3 is because I have a multiplicity of 2 here, a degree of 2 for that particular factor, and a degree of 1. If I were to add those together, that would be a degree of 3. So since it's a degree 3, I know I'm looking at it like a line, a positively sloped line. So my positive end is going to be positive, and my negative end will be negative, yes? Okay, so there's the end behavior follows, zeros, multiplicity of multiplicity of 2 at negative 3, and a multiplicity of 1 at 2. So again, if we were to take a snapshot, at 2, I should see a line. Do I see a line? You're darn tootin', I see a line. At negative 3, if I were to take a snapshot, right, and just look strictly at what's inside of that circle, I should see a quadratic. Do I see a quadratic? Yes, I do. So I know I did it correctly. All right, last couple examples here. So now we're going the other way, okay? Previous examples, we saw a function, and then we had to graph it based on what we know about multiplicities of factors, right? Okay, now what we're going to do is we're going to look at a graph, and we have to actually come up with the equation or the function. Make sense? Okay? All right, so it says what we're going to do is look at the degree of said function. Well, let's do it. Okay, so what did we say? One way to find the degree is by looking at the increasing and decreasing intervals. I will tell you that is a perfect way to look at the degree of a polynomial if all of those particular zeros have a multiplicity of 1, and in some cases it doesn't matter, it still works out. What I would tell you though is if it does have multiplicity, I would start looking at the zeros. Do you understand? Okay, and that will give you the degree. So let's find out. At negative 2, hopefully, I'm going to use a different color here. At negative 2, hopefully everybody watching the video can tell me that at negative 2, do you guys agree I have a multiplicity of 2, yes? Right? Multiplicity of 2, okay? At 0, hopefully, again, I'm looking at the snapshot there for both of those. And they both, if I were to just to look in the circle that I circled either in red or blue, I notice there's a quadratic, right? And I know that a quadratic produces a multiplicity of 2, right? Or degree of 2, because it happens twice, right? And then lastly, if I were to look at 1, and I look at just what's inside the green circle, all I see is a line, correct? So I know that has a multiplicity of 1. Okay? So as far as the degree goes then, I'm going to add 2 plus 1. Therefore, the degree here is 5. And that should make sense that it's odd, right? Because both ends are going in opposite directions. Yes? Okay? So the real zeros in this case are x equals -2, 0, and 1. Yes? Okay? So I hope there's people watching this and saying, well, Mr. B, that doesn't make sense. Because you told me the total number of zeros, the degree tells you the total number of zeros. And I only have 3, real zeros, but my total degree is 5. Okay, and maybe some of you aren't. Maybe you're saying, well, that means there's 2 imaginary. I will tell you that that is not the case. And the reason that's not the case, guys, is because, remember we said multiplicity is how many times that particular solution happens. So -2 really happens twice, right? So times 2. 0 really happens twice, right? So times 2 and 1 happens 1 time. So 2 plus 2 plus 1 is 5. So really, there are no imaginary solutions. There's just 3 real solutions. Those real solutions happen to happen more than once. Does that make sense? That we would only write them 1 time, okay? So real quick, end behavior. As x approaches infinity, my y value is going down, right? So y approaches -infinity. As x approaches -infinity, my y value approaches positive infinity. And lastly, let's talk about the equation, okay? So I have y equals, and again, since my solutions, I know one of my solutions is -2, what factor is produced from the solution -2? That's x plus 2, correct? Because if I were to set x plus 2 equal to 0, I get x equals -2, don't I? Right? So the factor that produces a solution of x equals -2 is x plus 2. I know the multiplicity is 2, right? So what do I have to do? I have to square that particular factor, right? Because at that factor, there's a quadratic, right? And what do we know about quadratic's degree? It is 2. How about x 0? Okay, so that would just be x, or x plus 0, right, which is just x. And what do I know is happening at that 0? There is another quadratic, therefore I need to square that factor. And lastly, the factor that produces a solution of 1 is x minus 1. And we all agree that I'm not going to raise x minus 1 to anything because the multiplicity here is just 1. Okay, now typically we would reorder this, right? We'd probably put this lone factor right here out front. So it would be y equals x squared, x plus 2 squared, and then x minus 1. All right, I would strongly encourage you guys to look at example number 9, do it yourself, pause the video, and then see what the answer is. All right, here we go. Real quick, if I were to look at that particular graph, I know the degree is 6, and the reason the degree is 6 is because if I look at the multiplicities, right? Once we start getting into multiplicities, the increasing and decreasing interval thing does not always work. So if you ever see multiplicities at zeros, I would definitely just look at the multiplicity of the 0. Okay, so let's take a look here. At this particular 0, it looks like a line, so that's a multiplicity of 1. At this particular 0 of -2, it looks like I have a quadratic, right? If I did a snapshot, so that's a multiplicity of 2. And then over here at 1, it looks like I have a multiplicity of 3 because that looks like a cubic function, correct? Okay, so 1 plus 2 plus 3 is 6, therefore the degree is 6, and it should make sense that that is the case. Oh no, look at that. I totally messed this up, guys. Go back to example number 8 here real quick. The leading coefficient here should be negative. Do you guys agree with me there? Okay, and the reason it should be negative is because the ends of my graph are going like a negatively sloped line, correct? Okay, so that was my fault. Hopefully you caught that, but if you didn't, go back to number 8, change the leading coefficient to a negative because, again, the ends of my graph are going in the direction of a negatively sloped line, okay? So if we go back to example 9 real quick, I know it's a positive leading coefficient because the ends of my graph are both going up, like a positive leading coefficient of a quadratic. The real zeros, again, are where it crosses the x-axis, so I have them labeled here. X equals -3, -2, and 1. End behavior hopefully makes sense since we've done that a lot over the course of the last week or so. And then possible equation is this. X plus 3 is the factor that I would need to get a solution of x equals -3. I know that has a multiplicity of 1, so the degree here is 1, right? That's why I didn't put anything there. X equals -2. The factor that produces that is x plus 2. At the solution -2, if I were to just look in that blue circle, I see a quadratic. Therefore, the multiplicity is 2, or the degree is 2 for that particular factor. And then x minus 1, if I were to look in just that green circle there, I see a cubic function. Therefore, I would need to raise x minus 1 to the third power.